At 3:47 p.m. hours on June 22, 2025, a Russian locomotive engineer checking his schedule had no idea that Ukrainian eyes had been watching his fuel train for the past 73 minutes. In exactly 94 seconds, 840 tons of diesel fuel would become Ukraine's newest fireworks display, courtesy of $8,000 worth of modified hobby drones, 35 kilometers away. Ukrainian operators from the elite Kabul 9 special unit monitor thermal feeds through encrypted Starlink connections. Their modified DJI Mavic reconnaissance drones paint the target with surgical precision. The thermal signature doesn't lie. That locomotive's diesel engine glows white-hot at 47 C against the cool morning landscape, while the 12 fuel cars show subtle temperature variations that scream premium target to anyone working with brain cells. But this isn't some spur-of-the-moment operation. Ukrainian Defense Intelligence has been tracking this specific train for 96 hours using a network of partisan spotters equipped with encrypted smartphones. They identified its departure schedule from the Rostovan fuel depot, typical speed-through this sector, and most importantly, the 20-minute window when it would be furthest from Russian air defense coverage. The math is brutal for Moscow. Each fuel car carries 70 tons of diesel, enough to keep a Russian tank battalion operational for 3 days. 12 cars times 70 tons equals 840 tons of fuel, roughly 10 days of operations for 3 armored battalions. Those 10 days can make all the difference between the Russians breaking through or simply sitting around like very expensive lawn ornaments. And here's what makes this strike package even more terrifying. Those aren't your standard DJI drones anymore. Ukrainian engineers have retrofitted them with experimental firmware, extending digital zoom to 56 times magnification and flight endurance to 45 minutes. More importantly, they've integrated custom RF hardware with frequency hopping spread spectrum technology that changes frequencies 1,500 times per second across multiple bands. It's like playing electronic whack-a-mole, except the mole can't be caught. And unlike that carnival game, these moles fight back. Each Ukrainian-built FPV quadcopter carries a modified PG-7 VL-shaped charge warhead weighing 2.6 kilograms. That's an 2,000 diameter copper line cone that focuses explosive energy into a jet traveling at 35,000 feet per second, fast enough to turn 15 millimeters of Russian steel into confetti. The warhead was originally designed to penetrate 500 millimeters of rolled homogeneous armor against a fuel car. It's like using a sledgehammer to crack an egg. The train continues rolling through occupied territory at exactly 45 kilometers per hour, completely unaware that in 47 more seconds, this routine supply run will demonstrate why occupying Ukraine was the worst investment decision since someone bought blockbuster stock. At 03 for 8 hours, as the first strike drone enters its terminal approach, something changes the electronic landscape entirely. A Russian Lear-3 electronic warfare system suddenly surges to life. Its operators finally spot the electromagnetic signatures they've been trained to hunt. The truck-mounted system begins broadcasting jamming signals across a 30 kilometers radius, pumping out enough RF energy to disrupt every civilian cell phone from here to the next village. The Lear-3 isn't subtle about its approach. First comes broadband jamming, high-power noise transmitted across multiple frequency ranges simultaneously, designed to overwhelm any receiver within its engagement envelope. When that proves ineffective against Ukrainian drones' frequency hopping technology, the operators switch to spot jamming, focusing intense interference on the specific 2.4 GHz and 5.8 GHz bands that commercial drone systems typically use. It's like your wife first blasting the vacuum cleaner to drown out your music, and when that doesn't work, she tries to unpair your Bluetooth speaker so you can't hear a thing. But Ukrainian operators had anticipated this exact scenario. Their system employs advanced frequency hopping spread spectrum technology that laughs at Russian jamming attempts. The drones change frequencies 1,500 times per second across 4 separate bands simultaneously, making it nearly impossible for the Lear-3 to lock onto and disrupt the signal. The Russian operators intensify their electronic assault, moving beyond simple GPS jamming to GPS spoofing, sending false satellite signals designed to trick the Ukrainian drones into believing they're somewhere over the Pacific Ocean. It's a sophisticated attack that would fool most commercial systems. But these aren't typical drones. Inside each Ukrainian attack drone are precision solid-state gyros that detect the discrepancy between GPS data and actual movement patterns. The inertial measurement units don't need satellites, they track every change in velocity and direction using the fundamental laws of physics. You can spoof GPS signals, but you can't lie to Newton's laws of motion or something like that. As the lead attack drone approaches its target, it unspools what looks like a fishing line, except this line carries light instead of lure. The fiber optic cable you see here maintains a perfect digital connection to operators 35 kilometers away. Now the readers understand why Ukrainian operators chose this over radio control. You can jam airwaves, but you can't jam glass. The fiber core measures just 9 microns, thinner than a human hair, while maintaining 1.5 gigabytes data transmission rates. That's enough bandwidth for uncompressed 108p video, while simultaneously carrying control signals, telemetry data, and GPS corrections. More importantly, it creates zero electromagnetic signature to Russian sensors. The drone appears autonomous, a robot acting on pre-programmed instructions rather than receiving real-time human guidance. But physics doesn't give free lunches. The fiber optic cable adds weight and bulk, requiring larger drone frames and more powerful motors. The hard connection between pilot and drone also leaves a physical trail after every flight, a reflective strand that becomes visible as it accumulates. Ukrainian operators know they'll need to relocate after this mission, but that's a small price for guaranteed connectivity. At 0348, despite maximum power jamming across every frequency band the LER-3 can generate, the Ukrainian attack drones maintain perfect control. The Russian operators watch their expensive equipment accomplish exactly nothing, while the drones approach their fuel train at 160 kilometers per hour. The electronic chess match is over. Physics just checkmated a $5 million electronic warfare system with what amounts to a very long extension cord. At 0349, the first Ukrainian attack drone impacts fuel car number 4 with surgical precision. The 2.6 kilograms PG-7V-L-shaped charge doesn't just explode. It vaporizes a precisely engineered hole through 15 millimeters of steel at 2,800 C, instantly converting 70 tons of diesel into an expanding fireball that announces to everyone within 20 kilometers they should stay out of Ukraine swamp. But here's where things get interesting in the worst possible way for the Russians. When that jet hits the fuel car's steel wall, it doesn't just penetrate. It literally liquefies the metal and pushes it aside like a hot knife through butter. The fuel inside doesn't have time to leak. It vaporizes instantly, creating a pressure wave that treats the car's structural integrity like a suggestion. The explosion rips through car number 4's interior at temperatures exceeding 4,000 C. But the real devastation comes from something Soviet engineers never anticipated. The interconnected ventilation systems between fuel cars, designed for pressure equalization during loading operations, now become a highway for destruction. Within 20 seconds, burning fuel vapors have ignited cars number 3 and number 5, turning 3 separate targets into one massive fire. Russian crew members finally spot the second attack drone approaching car number 8. Their response is immediate and completely ineffective. AK-7 for assault rifles firing 5.45mm rounds at a target, moving 160 km per hour and maneuvering in 3 dimensions. It's like trying to shoot a hummingbird with a shotgun while riding a mechanical bull. The small arms fire forces the drone into wild evasive maneuvering, but the operator maintains control through the chaos. Meanwhile, the first drone-shaped charge decides to demonstrate that Ukrainian engineering isn't always perfect. Instead of the clean penetration expected, the warhead achieves only partial detonation, leaving car number 4 ruptured but not completely destroyed. The operator, watching through crystal clear fiber optic video, makes a split-second decision that's equal parts brilliant and insane. He guides the drone's burning wreckage directly into the spilled fuel, using the drone itself as an incendiary device to complete the job. Then physics intervenes in ways nobody anticipated. The massive fire creates its own weather system characterized by thermal convection currents that generate updrafts and downdrafts with wind speeds exceeding 60 km per hour. The third attack drone approaching car number 11 suddenly finds itself fighting hurricane force winds generated by its own mission success. But the problems compound when the second drone's fiber optic cable snags on a railway signal post, limiting its maneuverability to a 30 meters radius. The operator now faces an impossible choice: abort the attack and waste months of preparation, or attempt a precision strike while tethered like a flying yo-yo. He chooses the latter. The locomotive engineer applies emergency brakes, but 840 tons of rolling mass doesn't stop on command. Normal circumstances don't include multiple fuel cars, burning at temperatures that can melt copper. The stationary train just became an easier target. As car number 4 transforms into a fireball, the massive blaze creates convection patterns that turn the remaining attack drones into aerial knife fights. The second drone operator fights cable tension, wind shear, and small arms fire while lining up his shot on car number 8. In 33 seconds, he'll discover that sometimes the hardest part of precision warfare isn't hitting your target. It's hitting it while everything else is literally on fire. At 3:50, the third drone pilot fights convection currents rising from the burning fuel cars. Wind shear from the thermal column throws his approach off by 15 meters, forcing a desperate course correction as small arms tracers streak past his camera feed like angry fireflies. But the fire doesn't just create wind, it creates something else entirely. The massive fire smoke particles scatter laser designators and degrade visual targeting. While the heat shimmer throws off IR sensors, the operator finds himself flying, essentially blind, navigating by thermal signature alone through a self-generated hurricane of superheated gases. Meanwhile, the fourth drone operator faces a different nightmare: battery degradation. His quadcopter shows 18% power remaining with 90 seconds to target. Ukrainian engineers optimize these drones for endurance, but fighting wind resistance from thermal updrafts drains batteries faster than anyone calculated. He has one chance: to reach the locomotive, or his drone will fall harmlessly into the countryside. The second drone, still fighting the snagged fiber optic cable, approaches car number 8 like a tethered falcon diving for prey. The cable tension affects thermal velocity calculations, but the operator compensates with pure flying skill. At a closure rate of 60 meters per second, he has exactly 1.3 seconds to adjust the cable drag before impact. The simultaneous strikes come moments later. Drone number 2 slams into car number 8, while drone number 3 targets car number 11, their shaped charges detonating within milliseconds of each other. The overlapping blast zones create constructive interference, pressure waves that amplify rather than cancel, turning to separate explosions into one sustained detonation. However, the real devastation lies in what happens next. The sustained fires, now approaching 1,200 C, begin affecting the railway infrastructure itself. Steel rails designed for 60-ton locomotives start warping under thermal stress that exceeds their engineering specifications by 300%. What was once precision transportation infrastructure becomes twisted metal sculptures that would be perfect for a modern art museum. The fourth drone, running with 8% battery remaining, executes the mission's final strike against the locomotive. The operator has no margin for error. Miss this shot, and a $2.4 million piece of rolling stock survives to haul more fuel tomorrow. The PG-7 L-shaped charge punches through the engine block with mathematical precision, ensuring that even if fuel cars survive, this train will never roll again. The economics tell an even better story: $8,000 in modified commercial drones versus $2.4 million in destroyed rolling stock, plus 840 tons of fuel worth over $600,000, plus 3 weeks of supply disruption affecting 3 armored battalions. Not even the best Wall Street hedge funds could get you a 30,000% return on investment like that. Bye for now.